Oh boy. Alright, so it's super broken. It is completely fucking busted. Oh hey, where'd he go? Oh. Huh, that's weird. Oh my god. There we have something. There we go, there's my world. It's running at 72 FPS, which is really bad. And we get this. Gonna be testing this a lot now, so let's copy the components. So I actually have no clue why it's not working. And that's a problem. I mean, it's obviously something here, but I'm thinking I might need to do something like this. Let's try something simple. Sine radius here. Well, that didn't work. We're probably gonna have to just go through the math again. Which is the last thing I want to do. I did save the math, but I'm not convinced that I can interpret the math today. At least I thought I saved it. Saved code backup. I don't see the math here. Right, I guess I didn't save the math. I was pretty sure I did. Yeah, there it is. I called it code. It's brick skipping code. So here it is. We got abs, signed radier, times float 3.8. The side dist here is 8, 6.2, 1.2. And here I'm saying if one ray is negative, minus 6.2 here. Then that gets absed, and then we get a distance here. So we have minus 6.2, and to get to minus 8, that's minus 1.8. So then we get the distance there. So far it seems right. And then we take the distance, divide it by side dist delta. Now here's where things get a little spicy. Because I don't know if the deltas are negative. We kind of have to do a little check here and go through this calculation and see if the delta dist can be negative. It cannot, because it's absed. So the delta dist is always positive. Okay. I think this is still right, though. And then we do this. Side dist delta divided by delta dist. Then we get that value. And then we scale this up by the get vector scalar. That's the part where I don't know if it's right. And then scale the delta dist, which is still positive, gets added to the side dist. But that's what happens here too, right? And so that should be fine too, in my opinion. And then map position. We got length check. Hello, Land 3D. Is this a voxel system for a Unity game? Yeah, I mean, I'm just using Unity as a base, really. But yeah, I'm making some brick maps, and I'm raycasting in a compute shader. Right now, I'm trying to figure out. I don't know if you know what a sparse data tree or a sparse data structure is, but the idea is that the alt tree contains a bunch of bits that tells us if any of the voxels inside the brick contains any data that we want. And if all of those are false, then we just skip the entire brick instead of raycasting through the actual voxels. But I'm having some trouble with the math. New to C#, but have been making game art for 10 plus years. Alright. It's an optimization? Yep. It's so that we skip as much as possible if we can. But the math just feels like it checks out. Not really sure. Well, I mean, the map position ray step. Yeah. That could be it. So we have map position here, and we're getting that. And what if we multiply that by ray step? And then we give it a try. Nope. Still broken. Not supposed to be a black hole. No, I don't think so. Because all of this has to work. I mean, this is where it doesn't work. And all of this is part of one step, right? So the idea is that let's say, I don't know what color they usually are. You've got X here, and you've got Y, and you've got Z. Now, I don't know if this is gonna make any sense. If you're moving here, like let's say you start here, and we're going there, for example. Now you can't really tell the Z, but what's gonna happen here is that we're gonna get, if we're just gonna assume our values, it's gonna be something like a float 3, and this is gonna be maybe 4 point that. The Y is gonna be 1.2 above, something like that. And the Z looks pretty small as well, so maybe like 1.4, whatever. And the idea here is that the higher the value, the further the ray has to travel before X is incremented, right? So that's just how it works. It's going up really steeply, so X barely gets incremented. It still gets incremented a little bit, but not as often as the lower values, like Y, which is just straight up. And Z is a little less straight up. And what you do is that every time you do an iteration in the loop, you check which value is currently the lowest, because you also have like, where did we start? So you have another position that's like the camera is, let's say we're like 2 point whatever, 1.1 and 1.2, That's like our offset into the voxel that we're standing on, or standing in right now. So that's where we start. And then this value will get added on to that. But we always add whatever value is the lowest. So I don't know exactly how it would turn up here, but it would probably be like we add y first, and then next time we add plus z, next time we add plus y again, next time plus z, next time maybe we finally get to x, I don't know. And this tells you, this is like how the ray is traversing. It also tells you, because we have a map position as well, which is like the index. So it's like we're currently in like voxel 001 or 002 or 012, you know. It's just an XYZ integer coordinate. And the last one that we added, that also tells us the face of the voxel, like is it the left side, the front, or the top, or the bottom. But now that we are trying to skip space, you add them to the index as the raycast passes through them. Yeah, here. You see here we add side distance times delta distance. Or side distance plus mask. That's a float 3 boolean. That's like false, false, true. Multiplied by the distance that we want to step. And then this tells, just controls like if we're adding x, y, or z. So this gets added to our current distance. But after that, we also add the same thing to the integer position here. So both happens. And the problem is that this works fine for like doing one step. But once we get to the edge of the brick, a brick is a 8x8x8 container for voxels. So once we get to the edge, we have to check the next brick and see, is this brick empty? And if it is empty, then we want to skip it. But how do you do that? That's the tricky part. Because what I could do is like, I could literally just make a while loop and just like iterate through everything a bunch of times. But that's the same as just going through it normally. So I have to figure out a way to cast the ray to the end of that brick, right? And my idea for that was, and this is where it gets really complicated. It doesn't need to track its neighbors. All we need, I mean, they can. I think you can do that. There's something called roping. Like you can have a rope to the next voxel or the next brick. But what happens is that once we get to the end of the brick, we can just calculate where we are. So we could, because we have a grid, so we know based on our position where we are in the next brick. So we know exactly how far we have to like the right side or the other side. But the problem is iterating these values properly. Yeah, exactly. Well, I think. So what I'm doing is this is the math, right? Sine ray direction. That's just which way the ray is traveling. Let's say that's 1, 1, -1, right? Because the sign is just, if it's positive, then it's 1. If it's negative, then it's -1. That's all you get. then I multiply that by a float 3 of 8s. And what that will give us is a float 3 of 8, 8, minus 8 in this case. And 8 is how many voxels are in each direction in a brick, right? And that's how many steps you would move. And then we have that. And over here, after we've multiplied those together, we do minus, again, sine ray direction, which is, again, 1, 1, minus 1, times side dist percent 8. And this is, I don't know if you know what this is, but this is something called modulo. And it gives you the remainder of what this is based on that. So if this value is 4, then you get 4 in this case, because it doesn't reach 8. But if the value was 12, that's 4 above 8, then it would give you 4. If it was 10, it would give you 2. And if it was 18, then you get 2 again. So it just makes a value loop based on the value on the right. And what are we doing there? Yeah, that's... What am I doing there? Yeah. I'm taking my current position and I'm looping that with an 8, and it will basically cut off everything except for the last 8 or our current value, and that will tell us like which part of the current brick are we inside currently. And here, for example, I put in an 8, 6.2, and 1.2. And then that returns that we're at the edge of the brick in the X, because that's an 8. And 8 modulo 8 just returns a 0. 6.2 just gives us 6.2. 1.2 just gives us 1.2. If this had been 9.2, I would also have gotten 1.2. Example. So now we know where we are there. And then, now that we know where we are inside of the brick, we can use the ray's trajectory to figure out which side we will reach first, right? Because we need to know where we're going to exit. And I do that here I take this value that we just got. This is where we are currently. Or no, this is how far it is to the other side, rather, in each direction. I believe. Yeah. And then here I take that and I divide it by the delta distance, like the distance that we travel when we travel in the X and Y and Z. And that will give us an average amount of steps needed in that axis to reach the other side, right? And then I pick out the lowest of these values, because that's the side that will, if I'm not mistaken, that is the side that will that will reach the edge of the brick the fastest. So I take that, and then I take the distance that we need to travel here. And how do I get this value? I think that is 1.8 divided by yeah. There it is. That's 1.8, which is the distance, and then we divide it by how far we're traveling, which is 1.283. And then we get a value where we can just use this to multiply the if I multiply the distance we travel, 1.283, by that value that we just got, by 1.4029618, then I have moved our position up to the edge of the brick, I think. And then what I do is I multiply the other values up by that same multiplier. So we get 4.461 times 1.4029618 as well. And the same with the Z. So I stretch whichever is closest out to reach the edge of the brick, and then I stretch the other two axes out just as much as I stretch the other ones, relative to how far they, or how fast they travel, I think. That's what might be wrong. I might be doing it in like the opposite way, that they should be traveling less. But I think it should be right. And that's really the whole idea. And then I just add this value to the side distance. Because if you look here, this is how far we need to travel. In the X, 1.79. And here it's 3.97 to reach the other side. Wait, I mean, something is wrong, so there's something wrong with the math, so... Isn't it based on wherever the player is standing? It is, yes. Yeah. I just gave the player a position, and then I calculated the math based on that. And based on a random ray position, or a ray direction. But I think it's probably this here where I'm using the ray directions here. Because what do we get here? We get length check. That's side dist divided by delta dist. And yeah, this is just not correct. This is wrong. Because what's happening here is that this is treated like speed. But in reality, it's the opposite of speed. Or velocity. Yeah. Honestly, they just exist. Like they're just on a big array, pretty much. The brick map is less of a container than it is a way to check. Because really all we're doing is we're checking which brick are we in. Like we're in brick 4 right now. And then I just use that index to go and check my bit mask. And the bit mask will just be like 16 integers assigned to that brick map. And then I just look through them quickly, like are all of these 0? And if they are all 0, then I skip the brick. And that's pretty much the whole thing, really. But this is, again, this is the problem. No, the other way around. There are 512 voxels in each brick. Yes. What if I multiply this? I think that might make more sense. Because in reality, this one starts at the edge, so it has the highest distance, right? And it has 4, which means that the ray needs to move the furthest to increment the x. And that means that if I divide these, this value is way too low. This is by far the furthest to travel. So if I multiply them, then this is going to be how many ray steps it takes to reach that side. That makes a hell of a lot more sense. Eight times 4.461. Then we get 35.688. 1.8 times 1.283. 2.3094. 6.8. No, 6. No. 6. No. 6.8 times 1.710. Get 11.628. Now the question is where to go after this. I still think this might be correct, what I'm doing down here. But now we need to get some kind of multiplier. But we do have that. Because what we get here is how many ray steps it's gonna take to get there. Right? So then the question is, you would do 2.3094, because that's the rate that we're going with. And then we divided that by 4.461. And then we get... Then we get a coefficient to multiply with that value. I think. If we multiply that by 4.461. Hold on, this is wrong. I'm... .3094 divided by 4.461. There. But then if I multiply 4.461 by this, maybe it's enough to just... that times 4.461. I'm trying to find the next brick. But that just gives us the Y value again. I'm trying to figure out how much to increment our current distance or our current position. If you have the starting voxel and the last voxel within a brick, you can project to the next brick in that direction to see if anyone is home. If what you can do is, if we figure out which brick we're going to exit first, then we can just check that brick right away, and we can just iterate through that. You're correct. You're absolutely right. Because if we know that we're exiting on the right, for example, then we know that X needs to be incremented by 1. And then we can just check that brick. And then, you know, we can just keep going. More or less. But the problem is figuring out how to increment the ray right now. Because from the next brick, we would still have to know where we are in the next brick, so we can figure out which brick we're going to exit into next. And then you just keep skipping them like that, because we still need to know where the ray is going. And the voxels are technically not a part of it, but a brick is technically a voxel as well. Because it's just a lower resolution voxel. That's how it works. The bricks are just a collection of voxels, and when you're raycasting, you can raycast through the bricks instead of the voxels. And then when you reach a brick that says, I have things inside, then you increase the resolution, and you step inside it, and you start stepping through the voxels until you find a voxel or go to the other side, because there was nothing in the path of the ray. And right now, I can already ray trace the voxels. That's fine. But I'm just trying to get the math for skipping past a brick to work, really. I don't know if any of this would be the same. Like this delta distance, for example. That could potentially be just readapted to the brick. But I'm not sure. We'll re-examine that if this doesn't pan out. Yeah, there are a bunch of different. This is, like I said, this is called a sparse data structure, I think. And there are a bunch of different ones. There's something called an octree as well. And the octree just takes a square, and then you divide it by 8. And then you can take each other square inside that square that you just divided, and divide those by 8. And then you can do that as many times you want. And if you do that, you can check like the outermost layer, and the outermost layer knows if there's anything inside. And if there's nothing inside, you skip it. Or if it says that something is inside, then you go in, and then you start checking the other bricks. Though, since you know where your ray is, you know which one to check, or which octree node to check. So then you check like the bottom left one, and it says, yeah, it's still inside here, and then you go in, and then you go in, and you go in. Until it either tells you that, oh no, it's actually not like in the section that you're looking at, or if you find it. But I might implement that too, but I was told that brickmaps had pretty much the same performance when it comes to GPU raycasting, because let's say you have like a 5-layer deep octree. It has to basically, from what I've been told, it has to basically go into each layer and check for the thing, and then it can continue. And because it has to do these entries, it gets slowed down. It's still a good method, but it's not necessarily better than just a brick map, which is pretty much just a simplified version of it. Yes, exactly. The brick map it's just one layer. Like you have the big chunk, and the chunk is just like there's something here or there's nothing here. And if there is something there, then you enter it, and then you're just like right away at the voxel resolution, and you just step through the voxels. That's it. So it's a lot simpler, and because it just lets you go in, right, and then check. It's a lot faster, from what I understand. I'm not an expert at this. This is my first voxel engine, but I've been reading about it a bit. Yeah, exactly. It's like the top layer, and then inside you have 512 bricks right away. But the difference is that because it's only 8 times 8 times 8, you only need to pass through it like not that many times to get to the end, right? While with an octree, with every single octree, you might have to go in and check like 5 times, or 4 times, or 3 times for every single one before you can skip it. And that might just put you like on the other side of the octree, and then you have to like check that as well. So I think they turn out kind of similar. But here, what? Yeah, that's what I thought as well. Just a good place to start. Before we get this working anyway, it doesn't really matter what we're doing. Oh, my butt. But we've got this here now. Again, this is... It takes 2.3094 steps to get to the other side. What does that mean? How do I translate that into incrementing the other values? I'm thinking maybe something like this. You take this value. We get our distance, and then we take this value and we divide that by each value. Or rather, we do this, I think. And you check the axis of the voxel on the edge of your brick to assume the neighbor. I'm not sure what you mean. Now, the way it works is that you don't really know the axis of like anything. Like, you don't even know the side of what you're entering. Not really. Except that based on these values that you have when you're traversing the edges of the voxels, whichever value you traversed last, that's like the side of the voxel. That's really all I know. And then whatever side the next one is going to be, that depends entirely on whatever value is the lowest next. But what do we get if we do these divisions? 2.3094 divided by 4.461. That's float 3.7. And $2.3094 divided by 1.283. That's 1.8. $2.3094 divided by 1.710. We have these values. Now these are going to be the percentages that we're going to increment our side dist. I believe so. Then we do float 3. We have, these are our values. And then we add plus equals that times 0.5177. This times 1.8. This times 1.3505. 4.461. 4.461 times 0.5177. or rather side dist plus equals that equals plus f3 2.3095 1.283 times 1.8 uh-oh 1.71 times 1.3505 uh-oh I got the same value 3 times okay Is that just all I'm gonna do? I think technically it kind of makes sense. Just adding the same value to them all. Yeah, it does make sense because what happens is that what we're adding every single time is ray distance. Like that's how far the ray travels. Every time it travels in that axis. So if I just add a uniform value to them, that's just how far the ray has traveled. Think. No, we don't always add to each axis. We only add to one axis per step. But the math checks out for that. I've stolen it. Where is it? Ranch less voxel raycasting there. This is where it's from. It's something called DDA traversal, or yeah, a DDA algorithm. But again, it's basically like this, right? Like in this case, this is pixel art, right? So this ray is very low resolution, but it literally, this is how it works. You, through this formula, you know that whenever we step here, now this is a little bit misleading because it actually looks like that. more or less. Well, 13. Thirteen. 13 there. Yeah, so because we traverse x 3 times here, x is gonna be like 8. And then here we're traversing y all the time, so y is gonna be like 1. So what we do is that our current position is 0, 0, right? So then this is 0, 0, so then we check all of these against one another. So we check x against y and we check y against x. And if there was a z, we would check z against x and y. And then whichever one has the lowest value here, then it gets added. And that's 1. Then we add 1. And then we do it again. We check 8 and 0, or 0 and 1. But now it has to, like, I don't remember exactly how it works, but it like takes into account this value and it like adds it on here. So now it says like 8 there, and here it's like 2, and then it adds there. So now we're at 2, and it keeps doing that all the way up until we are at 8 here, I think. And then it's like, all right, now it's time to add the 8, because that's lower, or it's lower than or equal to that. So then this will happen. And then this just instantly gets set to 8, because that's when we traverse this whole thing over here. More or less. Or rather, I'm not very good at explaining this, but because I don't really understand it 100% either. But from what we just figured out, these values don't represent like where we are in X. It doesn't represent where we are in Y, etc. It's just a way for the algorithm to like understand which step are we taking now. So now that we have added this 8 here and we have 8 here, that actually means that we have traversed 8. Right? And then next step. Now this is going to be 8 plus 8, so that's 16. And this is 8 plus 1, so that's 9. So then we're back to adding once again. So now this is 9, and that means that now we have traversed 9 units along the ray, right? And the real position is that every single time we add something here, like every single time I add one to the y-axis here, that's when the map position gets incremented by 1. And then here, when we added this 8 here, the x would have get incremented by 1. So that tells us now we have moved 1 voxel in the x. So this isn't actually a position, it's just ray traversal, kind of. And that helps me as well, because that makes more sense in my brain. But what we need then is we need to just add the ray traversal to each axis. I think, I'm not sure if that is correct, but I feel like that makes sense. Or maybe it doesn't. No, I think it's this. All the way up here is where it's broken. Because here I'm still treating these as coordinates here. Yeah. Is there any continuation between one edge voxel and the closest edge voxel of the next brick over? I'm not sure what you mean. But they're just... The way it works is that they're stored in like a 3D order. So first 1 to 8 or 0 to 7 are the first 8 bricks, and they're stored in the first X, right? And then 8 to 15 are stored in Y1. And then it just goes all that way up until you get up here. And then the next row starts at X0, Y0, Z0, and then it starts down here again in depth. And they're all just stored in an array. Like that in 3D. But it's a one-dimensional array, but the data is ordered in 3 dimensions. But once the tricky part is that's for the first brick, right? So down here in the left corner you have 0, and that's the bottom left corner in the Z as well. And in the far right corner up here, that's 511. So that's the last tile, or the last voxel. But if you start at 0 here and you end at 0 here, if I go over one more step to the right, then we are at 0 plus brick. So this is brick 0 and this would be brick 1. Then we are at 0 plus 1 times 512. Right. So then over here I just arrive right there. Because it has to be like this. And then the bricks work the same way. Though I have to change that, I think. Though I'm not sure. Because then you got like 0, 1, 2, 3, 4, etc. But I'm thinking here what the math is like. Because the thing is, let's say we have a brick here. This brick is a simple brick. It only has this many voxels in it. It's 2D as well. If I go through this here, like say, like that. Well, let's go like this. Like that. Now, if I want to go up here, no, because the resolution of the incrementation is voxel based, so we're always moving one voxel forward. That's what the values are. I think, kind of. It's like because a square is it's further diagonally across a square, right? Than it is just straight across. So the more slanted the ray is, the further it has to travel to get to the next index. That combined with, well, I wonder if it's mostly just that. Well, I think it's that combined with like the angle of the ray in its own axis. Like an X-ray can go straight up, or it can go straight to the side, because it can go like this in a direction. So if the X is going straight like this, then it's gonna increment often. But if it goes like this, it still has to take into account that the voxel is gonna be longer there. So I think the value gets kind of changed a little bit based on that. So it's, from what I understand, it's always going to be jumping from this point to that point. So we're never going to end up inside the same voxel multiple times. So, but what I was thinking is, if I want to cross from here to there, we have to first go in here, and then we increment the y once with whatever value it has. And then we go over here to the right, and we increment the x with whatever value that has. So they're both only incremented by their value once. But if this was an empty brick, then I would check like how far is it to this edge, and then if I just check like, yeah, it's like 2 units or something, and then I just add 2 units to both of these values, that's not gonna end up with the same value that we would have had if we had naturally crossed through the voxels. And that's what's kind of weirding me out. I think I have an idea. Because here we need to add something to the map position, right? And what's gonna happen is we can figure out where all my math was. I think we want to do this. So what am I doing? I'm doing... We still haven't addressed that all of this is based on something that's wrong. But either way, I think the logic is still sound here. Kind of. It might still make sense. Because, at least to some degree, but either way, if we can get the distance here to make sense, then you take the distance, you multiply it by the distance needed to increment, right? And then we get these 35 to 11. Because we multiplied the distance based on that, and then we know which side is going to end up reaching the edge first. And then we take that value that we get here, and we divide that by the distance needed to increment. That way we get, on our x here, we get 0.5177. On our y, we get 1.8, and on our z, we get 1.35, whatever. And what we do then is we floor these, and then we simply multiply. We simply add 1 of each of these that have a 1. So we add 1 x step and or 1 y step and 1 z step, and then we increment the map position by 0, 1, 1. I think that makes sense. Because then that would be the same thing as here. Like if I go in here and we exit like almost right away here. Because that's what I'm doing here. I'm just going in, going through 2 voxels, and then exiting. Now I don't know if that makes sense with my like ray direction, but I think it might. Now the problem is here. I'm honestly really tired of doing this kind of stuff, because I've been programming something similar plus a level editor for our other project for work for a year at this point. So I want to just get to programming game mechanics. I'm actually an artist myself. Like, I'm not mainly a programmer. I'm a pixel artist. Oh, come on. Disappear. I make this kind of stuff. Got some stuff I'm working on here. Yeah. Bah, 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 bah. Oh, no, that one. There. And here I've got another little thing here. It's Supposed to be like a market square. This one hasn't been touched in ages. Am I the main dev on our project? I mean, arguably. But the the project lead is called Captain Kibbs. Or Kyle. He runs a YouTube channel called The Bickering Bunch. And we have like 10 plus people now. But on the actual game, like, we have a bunch of concept artists who design things, help Kibbs with channel art, because that's how we get our money. We have the YouTube channel that generates funds for the project. He also runs a gaming Discord called the Astrian Conclave. And but I'm the only pixel artist, and we have one or two other programmers, but they don't have nearly as much time as I do. So I do like most of the programming. And once I'm done with this, because I'm doing like the basic stuff, you know, rendering and level editors and bullshit like that. And once that's done, I'll have more time to go back to doing this again. We need our animations. That's a giant. I like the breathing animation, but Astrian, the second one. Right. That's the link. There's some posts, or there's a channel there called Legends of Terrestria under the Bickering Bunch, and that's the channel for the project. We also have a tabletop project in the works for a channel there too. This is just my side project. The problem is how do we figure out where we are based on the ray here? One way you could do it, I imagine, is if over here we can do the exact same thing here. No, I don't feel like it makes sense. I feel like I have it for the second half now, but I don't have this half. Because we have to figure out how far we have to travel. And I don't think this necessarily makes sense. That's the thing. I built 2D grid and labeled them all. No. I mean... Oh. I mean, we've done that a couple of times already, right? In here. But not exactly, not more precise. It's too annoying. But I am right. What we need is, we need to know where did we enter last, right? And we know that because we have already figured out which side we're exiting on. That's the first thing we figure out. The only thing that I'm not sure about anymore is how to get the distance to a side. Because now... we don't have that information. What I can imagine that might work is that we have a brick raycasting, like separate to this, kind of. Because here we set this side dist thing, right? And that's based on where we are standing within a voxel, right? Because that's what map position is. Map position is where the ray position is. Lord. And based on that and the ray position, we figure out our current delta or whatever inside the voxel. And then here in the delta dist, we calculate how far each ray travels to get, or the way it needs to travel. But what we can have is, we can have this, and at the same time we have the same system for a brick. But the way it would work is that while we're traversing a brick that has voxels, we just step through the voxels and we just add the delta distance to the voxel's own side dist. This, and I don't really know what to call the side dist. I want to call it like ray traversal or something. And once we reach the next brick, we just add the lowest step that the brick value has to add, because that means that now we have reached the end of the brick as well. So that needs its step, and then we increment that. I think that's probably a lot more sensible. Because then, if we get to the next brick then... I mean, I don't know if this is at all understandable, but... We just raycast normally through a brick with our voxels, and we check those, and we increment our side disks every single time we go through a voxel. And then when we reach the end, we increment, based on which side we exited on, we increment that side of the brick side disk as well. And then we check the next brick. And if that is empty, then we increment the brick's side disk based on its lowest delta dist or whatever, this whole thing, however it works. The problem then is figuring out how much, because then you have to increment the voxels as well. But I think that's where this thing that we just figured out comes in. You would just take the dist or the distance that you just incremented and do some division and figure out this 1.8 or 1.2 whatever, and then just floor that and multiply the delta distance and add that to the voxel side dist. I think that's probably the way to do it, but I'm wondering if I should take a little break and go for a little walk for 15 minutes, and then I'll be back. Probably an idea. Because I feel like we're this close to figuring out something that might work, but my brain is starting to slow down. I usually take a break every 2 hours when I'm working. So there's no step, I guess. But once we get back, I think we'll try doing that. We'll add a separate delta for a brick. In 3 brick map position, etc, etc. About 3 brick delta dist, etc, etc, etc. But yeah, I'll be back in. Oh, I already muted. Alright, dude. See you around. Thanks for hanging. Oh boy. Let's see if my brain can function or if I have to quit. Ooh. Does not like running. But now the ray direction is universal, so is the ray position. Because the ray position is actually ray origin. Running, yeah. But this is going to be equals int3 floor ray pos.xyz or floor ray pos times 8 dot xyz. No, divided by 8. There, so now we have a brick map position. And then delta dist, that's gonna be abs, float 3 length, ray direction, xxx divided by array direction. That's exactly the same though. It will be exactly the same. That means we don't need a brick delta dist, but we can keep it for now just to keep it easier in our brains. Now this will be different. Load 3. Brick map. Brick side dist equals sign. Redir times load 3 brick map position minus Middle mouse button has entered first stage of failure on the new mouse. And how is new is the new mouse? Maybe you just need to clean it. Maybe you just need to have less gunk on your fingers. I don't know. But the mouse wheel breaks really easy on most mice. It's really sad. Of course you can. The only mouse I've never opened is the rat. Because it's an engineering marvel. Often you can even get the skates or whatever you want to call them, the glides, back on pretty well if you just poke them open or peel them off. But I do hate that they put the screws under them. But you can also buy new glides. Skates. I call them skates because that's what the cool kids who were playing Counter-Strike bought. It was a brand called Skates with a Z at the end. But see, they're kind of tricky here because they're using the map position here because that's a 1, but they're kind of piggybacking on that for the minus ray position bit. It's like the ray position would be 1.2, for example. And then you subtract 1.2 from 1, which would be the map position, and then you get minus 0.2. I don't know what I did here, but I did not get the right values. Here, this is correct. And then it adds 1 to it. Oh, okay, so any... Okay, that's kind of tricky. Yeah, yeah. No, it'll work. It'll be exactly the same. Oof. Oh, my brain. So tired. At 4:30? Why? Isn't it already early enough? There's one way to wake up at 4:30. You just set the alarm at 4:30. Forever. Until your body is like, okay, I want to go to bed. And then it goes to bed. In like a month. Why do you need to wake up at 4:30? That's not your usual wake up time, right? Any other time of the day? Oh, terrible. Yeah, after you get home from work, it's kind of rough. Especially your work days. To be honest. But what you could do is I mean, it's still probably not gonna happen, but like set an alarm for when you get home, and then go on the treadmill for 10 minutes, and not an hour, for 10 minutes only before food, and just start with that and just get it going. But then you'll end up not making food instead. You're already terrible at making food. You know I'm right. Um, See, the trouble now is it's not so easy to figure out when you're at the edge of a brick. I don't know. I don't think it does. Not really. I don't know exactly what it does, but if anything, I can imagine that it might write some like registries that tells DirectX that like this game is installed and it's using DirectX or something. So that you can do like, you know, game specific settings or whatever, but I don't know, that's just a guess. You know, kind of like the NVIDIA control panel, for example. I'm thinking doing this. U in new brick equals -1. And then here we do new brick equals get brick. And then we say if... Well, this brick should be like... No, they can't, they're uints, they can't be minus... If new brick is not equal brick, Then we do traverse brick, check brick mask. This is heavy. We can't keep doing this over and over, for sure. And I think we honestly only need to do that. And then we can set brick equals new brick. So now what we need to do is if traverse brick, then we do mask equals less than equal brick side dist brick delta dist there. And now I need to be able to extract this. And for that, we're gonna need a function. No, not that. We need to extract Fuck. That doesn't give us anything either. See, I was hoping it would work, because I was hoping we would get some kind of value, but that's the thing, we don't have any values. So how the hell do you do it? The only thing I can imagine, and it's really complicated, I think, is we increment a side here, right? So if I increment y, for example, that we moved to the next brick in the y, right? Then I can use that value, because we know how many bricks are in each brick, right? That's 8 in the y. So that means that our new value in the voxel y is 8 times whatever the value is in the brick, right? So if we were at brick 1 and we go to brick 2, that means that we were at 7, and we're skipping a whole brick. I'm just thinking which order this happens. Because the brick is checked first. So since the brick is checked first, that means that we're at 8 inside brick number 1. And 0 is the first one, just to be clear. And then we check that the brick has something in it, and it doesn't. So then we decide to skip it. So then we go from 8 to the next brick. And that's going to be 2. So then we take 2 times 18, or 2 times 8. That's 16. So we go from 2 to 8 to 16. Now, what we have to do is we have to go into our delta and multiply the y by 8. Floor it. No. We multiply the y by 8, because that's like a distance needed to travel. And that means that we have traveled y 8 times. So then we get how far along the ray we have traveled. And then we need to go into the x and divide x by this value that we have here. That way and then we floor whatever we get from that. That way we can tell that, okay, we need to increment x twice. And we need to increment z 6 times. Maybe. That should work. Now, what we need to get here is my brain to remember what I just said. That's what we need. We need int new voxel map position. And we need to do int temp y or temp x equals float mask.x. What is mask? Why does this say float 3 mask? Oh, because it's converted to floats. Huh? We do this. Y, Z. And then we need to say int temp value equals max temp x max temp y temp z. Because these are going to be, because we're multiplying by the mask is going to be 0 or 1. Only one of these is going to have a value. Otherwise it's going to be 0. So if we do max temp x and then max temp y temp z, we get the maximum value from all of them. So then we do... Wait, why am I doing brace step? Should be brick delta. That. And then we need... But we also need... It's annoying when you have to dynamically pick out a certain value from a float 3. Because, let's see. Again, let's say we're at Y8 and we're traveling to brick 2. Int holy shit. So what we need to do is map position equals .3 map position.x map position.y. Fuck off. That's why. And then each of these needs to be set to oh, I think I have it. Map position needs to be set to brick map position times 8 plus map position.x. But this should only happen if the mask is true. So then we say times mask.x converted to float, right? So if this is true, then we set this to brick map position times 8 dot x plus map position plus x, but we don't want this map position, so what we're gonna do is we're gonna do times float, and if this works, times not mask.x. So then that'll reverse it. I don't know if that's gonna work in this context, but it seems like it. Oh boy. What's the difference between geothermal and... There's another one. Geothermal heating. That earth. Markvärme. Yeah, bergvärme. What's that in English? Alright. Focus a little bit more. We get the old map position, and then we get map position, and then we need another int called map pos differential, which equals first we do int3 map pos differential axis differential. This is gonna be old map, no, map position minus old map position, and then we say max map pos differential dot x max map pos differential dot y and map pos differential dot z. That way we have our axis differential here. Oh my god. And then we'd say Ah, here's where it fucks up. Well, no, we can still do it, but it still sucks dick. Well, can we skip a part here? Because here we get the map pos differential. Can we? What is it that I need to do? We get 080, for example, and what we need to do is we do float 3 dist traveled equals map pos differential divided by delta dist. And then we do, because then what we get here is, let's say we traveled 8y, right? Then we divide 8 by our delta distance, which might be, in our y case, that will probably be like 1.2. Then we get 6.666666, and then, for example, after that we need this value, and we divide. We take our other delta disks, and we divide 4.82 divided by 6.6667. That's 0. No, that's not right. It needs to be the other way around. 6.666667 divided by 4 point whatever. Then we get 1.5. Then we floor that, and then we know that we have moved one map position in our delta distance. So how do we do this? Then we do map pos differential, so that's 8 divided by delta dist. Then we get the axis differential here that needs to be a float. get my axis differential, which was 8 divided by 1.2. That's the distance traveled. And then we need to get this. Oh, this is so complicated. And then you need get this axis differential here. Well, no. Yes. No, it needs to be times delta dist here. Posting it. there, and then we do side dist plus equals floor in 3 map pos to add equals in 3 dist traveled divided by delta dist dot x dist traveled divided by delta dist dot y dist traveled divided by delta dist dot z. And then this is an int 3, so that should truncate it. Truncate. I should be able to just do this. Dist traveled, because even if you just have a float, you can still do .x xx like that. And that makes it a little bit nasty, dirty. Delta dist dot xyz. And then you floor it, just to be sure that it's flooring it. And then side dist is going to be map pos to add times delta dist and map position is going to be plus equal map pos to add. Now this is a little bit of a problem here because we've already added the map position, but I kind of want to do that instead. That way we don't add it there, we just make the calculation, and then down here we add it with everything, because otherwise I have to make like an additional calculation to avoid adding it twice. Not sure what this is. Oh, I have no idea if this works. It looks like absolute trash. And it looks super heavy. It doesn't work. Is there a reason why it doesn't work? It's not how retirement money works. Oh, wait. Oh, no, never mind. That's an integer. Doesn't matter. Wait, hold on. Not quite there, but I think it's getting better. It's running a lot better. Before this ran at 100 FPS. Now it runs at 500, looking up to the sky. So it's like actually skipping it. It's just that when it gets to the end, it's not drawing anything. So the question is what to do about that. Ready for early access? Yeah, it could be. Let me just implement gravity at least. Yo? Does it actually work? think it works. Yeah, my bad. So when I go up into an empty brick map or a brick, this should not happen. It's only like working in one direction too. Which is weird. It's like the negative direction too. I don't know where else to ask. Asking around a bit. Oh, wait, hold on. Oh, shit. Does it work now? Fuck! Ah! Now we get a big black thing. Alright. What happened with the temp value? I'm not using this at all. Hold on. No. Wait, no. Oh, wait. So close. I think this is... Possibly an integer value error. That's what this feels like to me. And the reason for that is you can see when I go up, it kind of the error it doesn't really update unless it's in a chunk kind of, and that kind of error usually means that there's an integer involved. But I think I might be done for tonight. It's so close, but what could be causing this? Not that one. This isn't used at all. Why? Oh, that's column. Look. There. Compiler returned 0. Compiler returned 0. What if I say int poop equals 2? And then I say bool test equals true. And then we say poop equals poop times 2 times float test. Compiler returned 0. What the fuck does that mean? I want an output. Alright, I'm not super interested in that website. I think that fjärrvärme thing is what they put in city skylines, forgetting like nobody but you does it. So the winter DLC was bizarre. Every house on a shared giant boiler. I don't think we do it that way either. Pretty much everybody handles their own heating here with wood or something. It's usually only the government-owned buildings that use remote heating. But not even that. I think even the school had a proper wood boiler. Shows it like what? I mean, I can't really say how it is in big cities. Yeah, no. It says that in the Swedish remote heating networks, they are calculating that 10% of the produced energy is lost under distribution. And the same average is roughly the same in West Europe. Usually lower losses in cities compared to small towns. But no, just think of it like it's just like a thermos. It's just a really long thermos for your coffee underground, pretty much. So it contains the heat pretty well. Want to go sit at a bar and eat nachos. But why? Looks pretty cool. But there's still a huge problem with this. The rays do not want to travel in double negatives. That's really weird too. It feels like I'm listening to two songs at the same time in this song. The Armored Core soundtrack is terrible. Oh. It's funny as well, once you go up here into the brick itself, it starts running like shit. We'll stop here. I can't figure this out. We'll simply have to go through the math again. Not much else to it. Again. Yeah, we'll continue tomorrow. I'm gonna go and drink veal milk and watch Chinese television, so... See you later. Thanks for hanging. Have a good night. Bye-bye.